Welcome back. Today we are going to discuss an AP Chemistry question. The link to this question has been given in the description of the video. All the resource links are included in the video description as well. The question is 0.10 molar aqueous solution of sodium sulfate Na2SO4 is a better conductor of electricity than 0.10 molar aqueous solution of sodium chloride NaCl. Which of the following best explains this observation? A. Sodium sulfate is more soluble in water than sodium chloride is. B. Sodium sulfate has a higher molar mass than sodium chloride has. C. To prepare a given volume of 0.10 molar solution, the mass of sodium sulfate needed is more than twice the mass of sodium chloride needed. D. More moles of ions are present in a given volume of 0.10 molar sodium sulfate than in the same volume of 0.10 molar sodium chloride. E. The degree of dissociation of sodium sulfate in solution is significantly greater than that of sodium chloride. I will suggest you to pause the video here and try to figure out the problem by yourself. Hope by now you already have figured this out. Let us just now discuss it together. So the question is about two aqueous solution. One is sodium sulfate and another is sodium chloride, and they have given a particular molarity for that, which is 0.10 molar. Now it is stated that sodium sulfate is a better conductor of electricity than that of sodium chloride. And we will have to choose an answer choice which gives the best explanation for this difference. I will go through each of these answer choice and we will see if that is a best explanation for this difference in conductivity or not. So the first answer choice says sodium sulfate is more soluble in water than sodium chloride is. Let us just look at this. So this is the solubility curve for different salts, but we are mainly concerned with sodium sulfate, which is in blue, and then sodium chloride, which is in pink. So this is the solubility per gram per 100 gram of water, and these are the temperature. So as you can see, till this temperature, which is a little below, or it is around 25 degree, so we can see that the solubility of sodium sulfate is less than that of sodium chloride. But after that temperature, the solubility of sodium sulfate increases and it remains higher than the solubility of sodium chloride till 100 degree Celsius. So we cannot say that sodium sulfate is more soluble than sodium chloride. It is not an universal truth. It depends on the temperature. If you are talking temperatures below 25 degree, then it is not true. The sodium sulfate is less soluble than sodium chloride. But after that temperature, yes, sodium sulfate is more soluble than sodium chloride. But for the conductivity, the sodium sulfate is always a better conductor than sodium chloride. So we cannot say that this is the best explanation for this difference in conductivity. Now let us look at the second answer. So the second answer choice says that sodium sulfate has a higher molar mass than sodium chloride has. Let us look at that too. So these are, just the mass of sodium, sulfur and oxygen. So you can just calculate it like this. So the molar mass of sodium sulfate is 142 grams per mole. So this is just rounding it. These are all the, we have rounded it. For more accurate calculation, you can always just take the numbers from the periodic table directly. But this will give you a good idea. This is the molar mass of sodium sulfate. And if I just, calculate and do it, we can get the molar mass of sodium chloride as this. So this is 142 gram per mole for sodium sulfate, and for sodium chloride this is 58.5 grams per mole. So definitely, sodium sulfate has a higher molar mass than sodium chloride. The statement is true, but that does not necessarily mean that this is the explanation for the difference in conductivity, and actually it is not. So the conductivity does not depend on the molar mass. So we can just disregard that answer choice. Let us look at the answer choice. So we came to see that A is not true and the B is also not true. Now C. To prepare a given volume of 0.10 molar solution, the mass of sodium sulfate needed is more than twice the mass of sodium chloride needed. Let us look at that. So molarity means moles of solute over liters of solution. What is moles of solute? It is the grams of solute, that means mass in grams of the solute divided by the molar mass. So molarity means grams of solute over molar mass times liters of solution. Since the molarity is the same for sodium sulfate and sodium chloride, and we have seen that the molar mass of sodium sulfate is much greater than the molar mass of sodium chloride. So in order for the molarity to be same, the grams of solute of the sodium sulfate must be greater than the grams of solute of sodium chloride. So the statement is true, but molarity has nothing to do with the conductivity of the solution. So this is not an explanation for the difference in conductivity between the sodium sulfate and sodium chloride. So let us go to the question and we can say that this is not the correct answer choice. D. More moles of ions are present in a given volume of 0.10 molar sodium sulfate than in the same volume of 0.10 molar sodium chloride. Let us look at that now. Okay. So 0.10 molar means, as we discussed, that molarity means moles in 1 liter. So that means we have actually 0.10 moles in 1 liter. So sodium sulfate, when dissolved in water, that's why I have written aqueous solution, it dissociates into sodium cation and sulfate anion. And if there is 0.10 mole, then we will get 0.20 moles of sodium ion and 0.10 moles of sulfate ion, as you can see. So how many total number of moles we have in solution? Because it is getting dissociated, so we will only have the ions. So we will have a total of 0.30 moles of ions that are moving around in the solution. What about sodium chloride? So if we have 0.10 mole, when sodium chloride is dissolved in water, so this is the aqueous solution, it dissociates into sodium cation and chloride anion. So from 0.10 mole, we will have 0.10 mole of sodium ion and 0.10 mole of chloride ion. So what we will have in solution? So when we dissolve it, we will have a total of 0.20 moles of ions. So this statement is again true. So we have more ions in solution for sodium sulfate than the moles of ions in case of sodium chloride. Now, whether this is the best explanation for the difference in conductivity? Yes. Why? Because the electrical conductivity depends if we are talking about any electrolyte or not. What is an electrolyte? Electrolyte is something which, when dissolved or melted, dissociates completely into cations and anions. And these ions actually, they carry the electric current. So if the number of ions are more, it will be a better conductor. So we can say that this is the best explanation, and I will also would like to add this thing here. So a solution like 0.10 molar sodium sulfate conducts about twice as well as 0.10 molar sodium chloride, partly because there are twice as many sodium ions available to move when a battery is connected, as we have seen previously, and also because sulfate ion carries twice as much charge as chloride ions when moving at the same speed. So answer choice D is the correct explanation. We have more moles of ions here in case of sodium sulfate when dissolved in water than for sodium chloride, and also the sulfate ion, if you see, it carries 2 negative charge and chloride carries 1 negative charge. So the charge is also higher. So the conductivity or the electric current carrying capacity, it depends that how many ions you have in solution and what is the charge of that particular ion. So we will go for answer choice D as the correct answer. Let me just choose green. So let me just choose my pen. So more moles of ions are present in a given volume of 0.10 molar sodium sulfate than in the same volume of 0.10 molar sodium chloride is the best explanation for sodium sulfate being the better conductor of electricity than sodium chloride. Now let me just look at this E and see what it says. E says the degree of dissociation of sodium sulfate in solution is significantly greater than that of sodium chloride. Let us look at that. The last option. Okay, so I would just like to introduce very quickly the concept of electrolyte. What is a strong electrolyte, what is a weak electrolyte, and what is a non-electrolyte. So an electrolyte is a compound that conducts an electric current when it is in aqueous solution, that means when it is dissolved or melted. In order to conduct a current, a substance must contain mobile ions that can move from one electrode to the other. Strong electrolytes, if the electrolytes are strong, they completely ionize in water. When ionic compounds dissolve, they break apart into many ions which are then able to conduct a current. All soluble ionic compounds are strong electrolytes. So what are the examples of strong electrolytes? Actually, the strong acids, strong bases, and the salts are example of strong electrolytes. Now, what type of compounds are sodium sulfate and sodium chloride? If you see, sodium is a metal and chlorine is a non-metal. So this is an ionic compound. Here also the sulfate is a polyatomic anion, and which are made up of all non-metals. So both sodium sulfate and sodium chloride, they are ionic compounds. They are soluble, so they are very strong electrolyte. So when they are dissolved in water, they break apart almost completely into the corresponding cations and anions, and they are very good conductors of electricity. So though we have seen that the conductivity of sodium sulfate is greater than sodium chloride just because they produce more number of ions, and also the charge of the anion is higher, but we cannot say that sodium sulfate dissociates much more strongly than sodium chloride because both of them are strong electrolytes. So this statement is not true. The statement becomes true only when we are comparing a strong electrolyte with a weak electrolyte. What is a weak electrolyte? The weak electrolytes partially ionize in water. They do not conduct electricity well because fewer ions are produced in solution. All weak acids and weak bases, they are weak electrolytes. And there is also another category which are non-electrolytes. If a substance does not ionize at all in the water, it is a non-electrolyte. So if we are comparing the strong electrolyte and weak electrolyte, we can say that the strong electrolyte dissociate much more rapidly than weak electrolytes. And if you are comparing a weak electrolyte and a non-electrolyte, that statement could have been true. But if you are comparing the strong electrolytes, you cannot say that the dissociation of sodium sulfate is much higher than that of sodium chloride. So that statement is not true, and of course it is not an explanation for that, for this particular question. So we got our answer. D is the correct answer choice. Thank you all for watching my video. Please hit the like button and subscribe to my YouTube channel, Sarko Research and Education. Here I post videos from test prep math question like PSAT, SAT and ACT math. I also post AP chemistry and AP biology question as well as dashboard analysis. See you all in my next video then. Nagode, happy learning.